Science and God. God and science. So logically, this talk should split into two bits. The science bit, where we're going to talk about how does science try to explain the world and look at a particular example. There's a particular bit of science that I want to try to explain to you, which there's something that happens when we do all of science that runs underneath the whole enterprise. And I want to sort of dig that up and have a very close look at it. It has to do with order and the laws of our universe. And then there's the God bit about can science fit into a Christian worldview, and are there questions that are bigger than science? So with that as our outline, let me give you a brief introduction to what's going on outside. Yeah, kill the lights. Let's just forget it. No one needs to see my face. Good. This is the sky above us literally right now. Good, 7:40. Okay? As you walked in, if you looked over that way, you would have seen a sort of remarkably bright star in the sky. That's Venus. If you don't, it'll possibly be set by the time I finish at about midnight, 2. Is that when I'm done? Venus is still remarkably high. As you go over, the next brightest thing will be Jupiter. Keep going, and near the moon, going from west to east, close to the moon will be Saturn. It'll be visible with the naked eye. And even further over towards now the eastern sky, Mars is up and will be up basically all night. So please get out and have a look at the stars. If you get nothing else out of this talk, please do that. You won't see Neptune, but it's up as well. When we try and do science, we try to understand the way the universe works. And there's always a beginning point that we start with. There's always some point where we go, what if the universe was like this? And then we see what we can explain from our beginning point. So I want to explain something very particular about the way that we understand the universe as physicists. And it has to do with energy. Physicists have been studying energy for a long time, right? There seems to be something that can be this quantity called energy that we can transfer from one form to another. We can turn electricity into light or into heat, for example. One of the things that physicists began to notice around the time of the Industrial Revolution was that there are more and less useful forms of energy. Energy is always conserved. There's always the same amount at the end as when you started, when you do all the tallying up, if you're careful. But there's a difference in the way that energy transforms. So, for example, if you start with a pile of logs and you want to build a fire and then turn those logs into a pile of ash, that's easy. All you need, if you've arranged the logs properly, is to simply drop a match onto it and up it'll go. The flip side of this doesn't work. There is nothing you can go and buy from the supermarket which you can drop into a pile of ash and it will turn back into some logs. Okay? If you want some logs, you need to go cut down some more trees. Sorry, I just need to set my timer. Good. That's telling us something. It's telling us that the same amount of energy is there at the beginning as the start, as long as we sort of keep track of everything, right? If you just keep track of where all the smoke ended up and where all the heat ended up, all the energy is there, but it is in more useful and less useful forms, right? The reason why you can turn this into a fire is because the energy is concentrated into the chemical bonds that hold the wood together. Once you've broken those, release the heat, release the smoke and all of that, you have a less useful form which will not turn back. So, for example, if you have a factory and you want to turn some form of energy with some other products into, say, a snowmobile, that's clearly the first bit of clip art I found when I was looking, right? We're all clear with that? Good, right? You can do that. What you can't then do is turn the snowmobile around, drive it back into the factory and hope to get some coal out the other end. That's never going to work, right? More useful and less useful forms, and there is a law of nature known as the second law of thermodynamics, okay? There are, in fact, 4 laws, right? We went 1, 2, 3, oops, we forgot one, and the other one's called 0. So 0, 1, 2, 3. Good. Here's the second one, which is really the third one. It is a law of nature that when you keep track of all the energy in a system, all the energy as it happens, it is always the case that you start with more useful energy and end up with less useful energy. Always. This is an absolute law of nature. This determines, we see this an awful lot in everyday life. This is one of the things that really is such a given in everyday life that we don't notice it. But what this means is that there are certain processes in the universe that only go one direction in time. Because the other way would be a transition from less useful to more useful, and that, according to the law and according to all our observations, never happens. For example, if you have a glass and you want to smash it, it's quite easy to do. You just throw it at any old bit of the ground and use your slow-mo camera to watch what happens to the glass, okay? So the cracks go all the way through the glass, all the pieces start shattering off in all sorts of random directions. There is the sound of the breaking glass that echoes around the room. That's how you smash a glass, we all knew that. If you want to rebuild the glass, here is what you don't do. You do not take shards of glass, scatter them on the ground, make a sound like glass shattering in reverse, and hope that it bounces off all the walls and all the bits start flying back together with just the right speed and rotation as they jump up off the ground. They all head back. Each bit ends up at just the right point for all those sound waves to come back together and to fuse it together. Now, let's all just stop. We all want to watch the fusing in reverse, don't we? So let's just not even pretend that you're listening right now. Right? It's good, it's coming. Right? And then it jumps off the ground. Yeah, this is totally irrelevant to my talk, but cracks in glass travel unbelievably fast, thousands of kilometres an hour. Anyway, that's totally irrelevant to what I'm going to say next. There's a way that things go in our universe, more useful to less useful. Starting about 100 years ago, or slightly more, physicists started to wonder why it is that some arrangements of the stuff in our universe are more useful and some are less useful. And so what they could start to think about is very simple systems like a box with some gas in it. And if any of you are familiar with physics, we're always talking about boxes with some gas in it. There's an awful lot of ways that you could arrange the particles in the gas as they move around and bounce around. There's different ways you could place them, different speeds you could give them all. And so we can think about what's a useful way I could arrange it. And one of the ways you would think about that is, how could I arrange it so that I could get some energy out of it? How I could transform the energy that's in here into another form? Well, here's one way of doing it. Suppose you arranged it so all of the particles were on one side of a barrier. Then, as they sort of shoot through this small hole, they could bounce off a wheel, turn the wheel, and hey presto, that could turn a generator or run your factory or whatever. And that's a way that we can get useful energy out of this arrangement. So all of the stuff on one side, that's useful because the energy there's a way, an easy way, a way I could actually implement of getting that energy out. On the other hand, if we just spread all the particles out randomly, even if we put a divider in there, on average that wheel would be hit in one direction the same number of times as it got hit in the other direction, and so the wheel wouldn't go anywhere. And so, for example, if you just sort of set one up in the air in this room, right, your steering wheel does not get turned by the air in your car. So that's a useless arrangement. But all that matters is where you put the stuff. One of the ways we understand this is by thinking about how many ways are there to make a useful arrangement versus how many ways are there to make a useless arrangement. So remember, with the useful one, we put all the particles on one side, all over on the left there. How many ways are there to do that? One. You just have to put all the particles on that side. Okay? You will get the same useful arrangement if you put them all on the other side and run it backwards, but that's two arrangements, okay? Within just the left versus right way of counting things. What if you wanted to make the useless arrangement? You've got to put half of the particles on one side and half on the other. That's the maximally useless way of arranging the system. Well, there's loads of ways of doing it. You could do it this way, or you could split them that way, or you could split them any other random way. In fact, there are, as you probably all know, 2,704,156 useless arrangements. Someone can check that for me later. I'm pretty sure I got that right. So here's starting with the work of a guy called Ludwig Boltzmann. As physicists started to think about useful versus useless in terms of how things are arranged, they came to the following realization. Useful energy happens only when you've got a particularly rare arrangement of the stuff in the system. If you do one of these common arrangements, if you just throw things around in there any old how, you get one of the useless arrangements, where you can't get any energy out. And in fact, with this little set of equations, we can think about the second law of thermodynamics again. Remember, we've known since before we were thinking about particles that more useful forms of energy turn into less useful forms, and the reverse processes don't happen, ever. But what this tells us is that rare arrangements, ways of arranging a system that are quite rare amongst all the possible ways of doing it, will turn into more common arrangements, and that is in fact part of the explanation of why that happens. If you just left the particles in that box and they just bounced around at random, they would naturally turn up with about half on one side and half on the other. This leads us to a puzzle. And the puzzle is simply this. If useful states are so rare, why is there any useful energy in the universe at all? If it takes a rare arrangement, a special arrangement, an orderly arrangement of things, of the stuff in the universe, in order to have a useful form of energy that will do anything at all, rather than just sit there doing nothing like the useless ways of doing it, why is there any useful energy in the universe at all if those states are so rare? And over the last 100 years, it's become quite clear what the answer is, once we've cleared away all the sort of nonsense of all the other ways we tried to explain it and failed. The answer is remarkably simple, so simple it seems like a cheat. It's called the past hypothesis. And all it says is that the universe began in a very, very rare arrangement with loads of useful energy. And that's all that you can say. That's it. You just have to say that you started off with loads of useful energy. Okay? Now, let me just counteract a confusion that might happen here. So if you're thinking hard about this, this might clear some things up. If you're not, then just enjoy this video. I've been talking about rare ways of arranging things and orderly ways of arranging things, but that's a physicist's understanding of what we mean by order, which doesn't necessarily sort of correspond with what we mean in everyday life. In particular, I don't mean something that a physicist might call complexity. So here's an example of the difference. Okay? If you have not found the slow-mo guys on YouTube, then go and do that at some point this evening. This is a very simple experiment where the starting point is just a fishbowl full of water and a syringe with some coloured ink in it. Now, at the start, this system is not particularly complex, and what I mean by that is it's easy for me to describe the system. Right? I just did it. Water in here, ink in there. What happens next is that they shoot the ink into the water and then film it with a slow-mo camera.
Fire.
Look at that. They're British.
Wicked. Whoa, look at that.
That looked really good.
That's cool.
As the system evolves, it gets more complex. And what I mean by that is to describe the way that the whole thing is arranged at this point would require a lot of information. I would have to describe every little lump and bump there in order to describe the system. Right? Later on, okay, that ink is going to dissipate into the water, and what I will have is inky water. So the system goes back to being simple again. So there is no second law of complexity. Complexity can go up and down. You can start with something simple, get something complex. You can start with something complex, get something simple. That's an example. The only reason any of that happens is because there is order, there is a useful, rare arrangement of things at the beginning. Okay, this experiment does not break the second law of thermodynamics. You would have heard about it if it did. Okay? But what this means is I can take the history of the universe and throw it into reverse, right, hit rewind on the VCR, right, old school, and find out where the useful energy in our universe came from, because it must have been in a more useful form in the past. So suppose I'm thinking about some ice melting in a glass of water, okay? That's something that's subject to the second law. It will melt. Like ice will not spontaneously refreeze at room temperature. No one's ever seen that happen. Ice never just sort of jumps up in your glass at room temperature. So that's a second law process. We get the ice from a freezer, of course. The freezer is run by electricity, which for us here comes from coal. And coal is essentially condensed sunlight. Sunlight hits plants, the plants store that energy, and then that very slowly on geological times gets turned into coal. So the coal is a useful form of energy. It's a condensed form of energy. Okay? I can burn it and produce ash. It's so useful. It's unfortunately polluting, but it's so useful because it is a useful form. I can create heat out of it. Why is the sun particularly useful? Well, the light we get from the sun, for every one particle of light that gets to us here, once it hits the Earth, heats the Earth up a little bit, it will be re-radiated as 20 lower energy particles of light. Right? The effects budget on this talk was astronomical. We can think of this in terms of of the number of ways of arranging. Before, right, all of the energy was on one side in that one particle. Now afterwards, it's split between 20. With that one high energy particle, same amount of energy start and finish, but with that one high energy one, I could do some useful, interesting stuff. Heat some stuff up. If I wanted to collect all of these particles, which have all taken off in different directions out into space, that would take a lot of effort, right? You can't just sort of reverse this process. Inside the sun, we can keep going back in time and think about where the energy came from and see why it's in a more useful state. The sun runs on nuclear reactions, right? This here is 4 hydrogen atoms undergoing a certain series of reactions, producing helium. That is the answer to the question posed in the opening line of Twinkle, Twinkle, Little Star. Okay? Okay. This side, doing well. Over here, pick your game up a bit. Excellent. For every one of these reactions at the centre of the star, by the time all that energy has actually come out of the star, we get 1 million of these particles of light. That's how energetic each of these reactions are, right? Four of these, turn it into helium-4, and you get 1 million of these super concentrated particles of light. So this beginning state here is a very useful form of energy, right? It's 1 million particles of light worth. We can keep going back in time because stars form when gas clouds collapse. So if you have a gas cloud, it might seem like it's just sitting there, but thanks to gravity, the thing can, in fact, and will, collapse under its own gravity and heat up as it collapses and eventually form into stars. So this is a useful form of energy because the laws of nature can transform this into this and ignite nuclear reactions. And so as we go further back in time, the way that the stuff in our universe is most useful is that it's all spread out, waiting to collapse under gravity into useful things like galaxies and stars and planets. So this is a sort of the universe's baby picture. This is what the universe looks like in its earlier stages. These are the hot and cold, or the dense and less dense bits of the universe. And the contrast here is 1 part in 100,000. So as you go to different bits of the universe, this is the whole night sky, like a map of the Earth, right? But looking up. As we look at different bits of the universe, it's all the same density, it's all the same conditions everywhere to 1 part in 100,000. So if you measure how much stuff there is in this volume here and how much stuff there is in this volume here, the answers will agree to 5 decimal places. That is useful because when gravity gets a hold of that, it can do a whole heap of stuff. And here's those simulations I promised. Here's what I actually do for a living. And this is kind of amazing to me that I get paid for this, so enjoy. We start with a computer and we take a part of the universe and sort of break it up into individual particles. We teach those particles, we program those particles, to feel gravitational pull from each other, to feel pressure forces, When they get very dense, they'll form into stars, and some of those stars will even blow up in supernova. And we put all of that in an expanding universe. We started off with those initial conditions we saw in the baby picture, and then we hit go on a computer. And if we tried to do this on that laptop, it would take 500 years, so we don't do that. We do a supercomputer. We have sort of 5,000 computers hack at this problem for a month, and you hope that nothing happens to the computer in that month. And what happens at the end of it is hopefully a picture something like how our universe makes stuff, how it makes structure at all. The short answer here is that gravity, is the hero of the story. Any lump or bump in the early universe, it's not perfectly smooth, but gravity can take that and make it collapse. That will release the energy there into another form, and in the process of doing that, you will make galaxies, which happen here at the very densest parts of the universe. Of course, if you've got a dense bit here, it's got more of a gravitational pull, so it will pull even more things in, so the rich get richer, and so the universe grows structure. What you eventually get is something called the cosmic web, for obvious reasons. There are the dense knots here where galaxies form, the empty bits here called voids, which sort of lost their matter to somewhere else, and then the bits of the universe that haven't quite decided which way they want to fall. In the middle there, those are called filaments. That whole process is energy transforming from one form to another. And it happens because at the beginning of the universe, there is loads of useful energy. The universe starts off in a very rare and very special state. And if you try to put something before what we think of as the beginning, which is going to explain that, then all you end up doing is sort of proving the same problem. You either break the second law and try to have less useful energy form into more useful energy, and that's a very bad idea. Let me illustrate how bad that idea is. There's a famous astrophysicist called Arthur Eddington who said this. Okay? He said, if someone points out to you that your pet theory, you've got some favourite physics theory, right? If it's in disagreement with Maxwell's equations, very famous equations about light and electricity and magnetism, if it's in disagreement, well, then so much for worse for Maxwell's equations. If it is found to be contradicted by observation, well, sometimes those experimentalists do bungle things sometimes. If your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation. Right? So you don't mess with the second law. It's one of those laws, right? And so that's why you just have to get to the beginning of the universe and say there was a whole heap of order there, because any process which took some general boring common state and made order in the universe breaks the second law, and then you have the wrath of Eddington against you. Whenever you've had some sort of, for any budding thinkers out there, when you have some potentially deep thought about Christianity or the universe or anything, philosophy, there's two things that are going to happen next. Okay, either A, C.S. Lewis has had this thought already and said it better than you, or B, C.S. Lewis has had this thought, said it better than you, and then shredded it. Okay, so thankfully this is A, right? C.S. Lewis already said this. This is 1960. If a man says Humpty Dumpty is falling, we see at once that this is not a complete story. We're missing something in that story, obviously. A nature which is running down cannot be the whole story. If a nature which disintegrates order were the whole of reality, where would she find any order to disintegrate? Which is everything I was trying to say, but on one slide, so beautiful. That's exactly the point I'm making. When we do science, at some point we end up at a beginning of our theorising, right? You just have to say, if the universe was like this, then the following things would follow from that, and you hope that then the universe looks like that. Right? Every successful scientific explanation of some fact about the universe today assumes an orderly special past. All of them, except the ones that break the second law, which we throw in the bin. This is important because we need to sort of look at what science can and can't explain, and to look very hard at its foundations. You need to know that whenever science always starts from somewhere, especially when we're thinking about fundamental things like fundamental physics, the basic laws, cosmology, the universe as a whole. Because there's two things really that science is, and we often run these two things together. There's what you might call science the method, where you say science is the following attitude, right? I'm going to go look really hard at the physical world around me and see what I can see and try and work out what's going on. I'm going to be as careful as I can. I'm going to get people to help me. I'm going to get other people to do the same experiments I'm doing. We're going to have controls. We're going to try and do things double blind. That's the attitude. I'm going to be as rational as I can and go and look at the world around me. The other part of science is what you might call science the knowledge, right? When we reach out to the universe with rational questions, the universe very often gives us rational answers. The universe we discover is in fact orderly, right? There are the laws of fundamental particles that we're all made out of that we can write down on a t-shirt, right? There are the laws of chemistry, the laws of biochemistry, the way that cells work, the way that your body works. You know, the knee bone is connected to the shin bone, I'm told. It's about as much as I know, right? All the way to weather systems and how planets work and all that sort of stuff. There's the stuff we've actually discovered about the universe by reaching out with rational questions. Now, the interesting thing is, it didn't have to be that way, right? If you look at the static on an old TV, you can approach that rationally and look for patterns, but you reaching out with your rational method, you will not get rational patterns back because the whole thing is random. Right? That is not what we find with the universe. When we reach out with rational questions, we get rational answers. Okay? So there are these two parts of science, and with that, let me get on to the God part. I was in Brisbane earlier this year, and there was a conference of Christians in science. We all got together in a big room. I was late for the bus and didn't have time to talk to someone who I walked past who had the following shirt on. Too stupid to try science, why not try religion? I should have just picked him up and taken him off to the conference, but he was a big bloke. Here's how I think what's going on in his head, okay? We used to believe in thunder gods, right, and rain gods, and a whole menagerie of Disney characters up in the sky, wind gods and sea gods and all that. One of the reasons we believe that is because nature was doing things, and people do things. And in particular, nature was doing chaotic, slightly crazy things. And people are sometimes slightly chaotic and crazy, right? The weather is obviously run by a person who is occasionally quite angry. Over time, believers in these gods got a bit bored of remembering all the names of the gods, so they rolled them all into one, and hey presto, there's monotheism for you. All you have to do now is add some rules and write a bit of scripture, and you've got yourself a religion. Ta-da! But, so the argument goes, science has shown us that the universe obeys consistent laws, laws of cause and effect. Okay, the gods don't do things to nature, nature does it to itself. When we look really hard at certain processes, right, wind and rain and all of that, we find out that actually the whole thing runs itself. We don't need gods to make clouds, evaporating water makes clouds. This is the water cycle, right? The whole thing runs itself. Just heat some water, it will evaporate, it'll make clouds. Clouds rubbing together will make static electricity, that's thunder, that's lightning, and then you'll have thunder, and then the whole thing is there, and all the gods are out of a job. More than that, fundamentally nature is not fickle. It obeys laws, the laws of science, the laws of nature. And so it obeys mechanical, mindless laws, laws that are the same all the time. So we don't need gods because nature is the cause of natural effects. And we don't want gods either because that's causing you some people some pain, but never mind. Because a mindless, mechanical causes of brainless, mindless matter will explain the laws of nature better than, Thor up in the sky. That, I think, is how the argument goes. So let me say a few things in reply. The first and most obvious one is, that's not our God. Some of you seem sad about that. Christianity is not warmed over polytheism, right? Not the idea that there's a whole heap of gods and then we just sort of roll them all into one and hey presto, we've got our God. A really great way to see the difference here is to look at, if you ask the nations around ancient Israel about how the heavens and the earth came to be, what would they say? There's a great story that we found on tablets called the Enuma Elish, which I recommend you go and read because it's absolutely fascinating, right? How was the heavens and the earth made? Well, there were these dragons and they had children, and the first story point in the story is the mother and the father dragon, Tiamat and Apsu, have had a whole heap of children, but the children are really noisy and so the parents can't sleep. That, my friends, is called common humanity that binds us all here and back there. What happens next is the father says, let's kill them. And the mother says, no, don't do that. And then it all kicks off, right? And so you can make a movie out of what happens next, right? There's scheming, there's dragon fighting, there's revenge and murder, there's magic. And in the middle of it, and if it was a 2-hour movie, this would take about 10 minutes in the middle. One of the losers is destroyed by one of the winners and turned into the heavens and the earth. Right? Ripped in half, half made into the heavens, half made into the earth. And the rest of the losing side is supposed to look after this heavens and the earth, but they complain, still complaining about it. And so the winning dragons, chaos monsters, say, all right, fine, we'll make someone to look after the heavens and the earth, and that's they take one of the other losers, rip him into pieces, and make mankind. Okay? And then they get back to the story about the dragons, and the whole thing ends with a feast with a whole heap of drunken dragons chanting the name of the head god, right? Marduk. Nope. Good. I probably shouldn't start chanting the name of a Babylonian god from the pulpit, should I? Good. That's a story. That's a great story. You could make a movie out of that. I told that story to our youth group. Okay? And then we looked back at Genesis chapter 1. And one of the kids in year 7, one of the boys, in classical year 7 boy style, looking back at Genesis chapter 1, said, quote, where are the dragons? Bingo. That's exactly the point. Okay? There is something kind of amazing going on in Genesis chapter 1. It is, and I mean this in a very technical sense, it's boring. There is no dramatic tension. Right? Genesis and Exodus are some of the greatest stories that mankind has ever told, right? The story of Joseph, story of the Exodus, right? Those are full of tension and characters. And Genesis chapter 1, there's nothing. It's like hearing your 5-year-old, and I've tested this, right, tell you about their day, right? I had recess and I ate my recess and then I did some stuff and then... It's just a list of things that happens with no tension about what happens next. There's no bad guy. There's no antagonist. Okay? There's no one fighting God, not even matter itself. It's just a list of God doing a whole heap of things that God wanted to do to set up the world exactly the way God wanted it set up. There's no Darth Vader. There's no Sheriff of Nottingham. None of that. God simply says, let there be light. And it was so. And at the end he says it's all very good. There's a fundamental difference in the way you see the world, depending on whether it is shaped by chaos monsters or Genesis chapter 1. If you fundamentally see the world as a mess, as chaos, as a place with no order, no rationality, then it's hardly surprising that when you are asked what is the natural world, you give an answer something like recycled dragon carcass. Once you write that phrase, it stays in the talk. If you read Genesis 1, on the other hand, you fundamentally see the universe as orderly, fundamentally see the universe as rational, as beautiful, and as good. So the difference there is the way that we see God. In Christianity, God has a number of characteristics. God is ultimate. God does not look outside of himself for the reason for God's existence. God has no parents. God is where all questions of explanation, of existence come to an end. God is also a mind, or at least more like a mind than anything else we know. God is rational, and so God's mind is really the definition of truth. God is also a unity. There is one God, okay? One source of existence and truth and goodness. God is also free. And in particular, when God creates, God did not have to create, and did not have to create this way rather than some other way. Finally, God is goodness itself, not just good by some external standard, but the standard of goodness. When you understand goodness, you understand the character of God. That's the thing that you are thinking about. If that's your picture of God, then your picture of the universe will be the flip side of that. The universe will be dependent on God at all times. The universe will be orderly because God is a mind, the ultimate mind. The universe will be consistent because God is truth. It won't have some random laws, so it won't behave differently today as it did yesterday. There won't be just some random changes here and there. Because God has unity, there will be a coherence to the whole story that the universe is and tells. There's a technical word there, contingent. Because God is free, the universe didn't have to be this way. It could have been a different way. Right? It's not necessary. Right? The universe is rational, but it is not inevitable. And finally, because God is good, his world is beautiful, fundamentally. Within the Christian worldview, then, science is simply looking at those things. It's just looking at God's universe and discovering in it the plan of its creator. So, for example, when we look at science, what we find is, first of all, another bit of technical jargon coming up here, but I'll define it for you. Science is not metaphysics. It does not answer ultimate questions of existence. We get to see the stuff that is, but science never answers the question why there is this stuff rather than other stuff, and why there is a universe at all. Because we are simply observing the universe and reporting what we see and seeing rational patterns within that universe. We find a science which is rational, which we can think through, which poses problems for us that we can solve. Another bit of jargon for you, but a quite important one. Science is inductive. This is a mode of reasoning where you collect examples of something, and from those examples you generalize. You make overall sort of summaries of the way things work. Okay? We haven't measured every electron in the universe, but all the ones we've seen have all had the same mass, and so we generalize from that to say that there are these things called electrons, which everywhere in the universe are the same. You need consistency if you're going to do that. You need the universe to behave the same way here as it does over there. Because there's a coherence to the story of the universe, there will be laws about the way the whole thing unfolds. There will be a rationality inside the universe waiting for us to discover it. We can think God's thoughts after him. This is a pretty important one because God is free. The universe could have been otherwise. And so if you want to know how the universe is, you have to go and look. You have to be empirical. You have to make observations. You cannot sit in your armchair and just speculate about what the universe is like. Okay? If you want to do some mathematical sum, you can just do that sitting here tonight. But if you want to know how many rings are there around Saturn, you can't do that sitting here with a pencil and paper. You have to go and look. You're going to need to buy a telescope. A little subliminal message for you. Good. Finally, there is an elegance to the ultimate laws of nature. This is something that physicists talk about. If you ever wonder what mathematicians do, what they are there doing is exploring very abstract ideas. It's very hard to describe. But there is something that all mathematicians sort of agree on, which is that what they are looking for is something that's particularly elegant, some nice way that these ideas all fit in together. There's an idea of mathematical beauty. Okay? It's a bit like if you were trying to learn another language. Say you started tonight to try and learn French. You would get a certain way through, come back in a week, you've had a week of trying to learn French, and I hand you a poem in French. You would not be able to appreciate it. Okay? You would be too hard in every sort of minor detail of it. But as you get mastery of it, you would realise that within all of the things, within all the ways to say things in French, the very best of poetry is just a really great way of saying that, a really elegant way of saying something. When you speak mathematics, when you can speak that language coherently and clearly and easily, the laws of nature are beautiful things written in that language. Very often in the history of physics, physicists have been pushed forward not by looking for maybe this will agree with observation, but here is a particularly beautiful way the universe could be. And time and again, that's been the right way. A very famous physicist called Paul Dirac once said, "It is more important to have beauty in your equations than for them to agree with experiment." Which is a remarkable thing for a scientist. We're supposed to be objective, right? So you don't think that this is just Christianity trying to catch up with the scientific revolution? Let me do two things for you. First of all, let me quote a very old Christian thinker from 415 AD, 1600 years ago, a long time before the scientific revolution, St. Augustine, who said, quote, "The ordinary course of nature in the whole of creation has certain natural laws, determining for each thing what it can do or not do. And over this whole movement and course of nature, there is the power of the Creator." That picture of science, that picture of we can approach the universe rationally because it has a rational creator, is not just Christianity trying to catch up with science. It was far and away the most common view of the world by the makers of the scientific revolution. The ones who actually did the hard work in the 15th to the 18th, 17th century, of doing the hard work when our understanding of the world, science didn't just appear out of nowhere, of course, but it took a massive leap forward in those centuries. Well, here's what I can do. Here's a list of the most influential scientists of the scientific revolution. And I've started with Nicholas Copernicus, who published his most famous work in 1542, 3, not a historian. And going through to Alembert there at the end is at the start of the 1700s. Okay? What I'll do is I'll put in bold all of the ones who had basically the view of creation and the world that I've put forward. They were believers in God. Right? Only D'Alembert, yeah, hang on, let me just, can you see they're all in bold, except for D'Alembert. I had to actually extend the list just to get an atheist on there. And he didn't start off as an atheist, he hung out with a philosopher called Diderot, and then who ruined him. That is basically the start there of the French Revolution. So atheism rises in that time in France fairly aggressively. But other than that, these are all believers in God, right? I've put a few asterisks there. There are some heretics, right? They do believe some rather odd things about God, but as a general rule, they looked for rationality in nature because they believed there was a rationality behind nature and its creator. Let me just illustrate this point quickly and then I'll bring this into an end. Here's a good way to understand the difference, the point I'm trying to make here. Okay? Explanations in terms of God don't replace or compete with explanations that we get from science. Here's an illustration. Let me ask the following question. Why does Harry Potter go to Hogwarts? Well, because Hagrid, the Hogwarts groundskeeper, takes him there to begin his schooling as a wizard. Same question. Why does Harry Potter go to Hogwarts? Well, because J.K. Rowling wanted to write the story that way. Those are both true. They do not compete with each other, okay? You would not get at a Harry Potter convention a panel of those who want to explain in terms of Hagrid versus those who want to explain in terms of J.K. Rowling. Okay, you will not get a fight between those two, because one of them is fictional. There is not two things here in Harry Potter. There's not the stuff that makes sense in the plot and the stuff that that J.K. Rowling wrote. The whole thing is hers. Right? The reason it all holds together, the reason why this is ridiculous, is because the arrangement is actually this. There is the internal world of Harry Potter, of Hogwarts, with its own internal logic, where things happen for a reason and we can ask things in terms of that world. Over the top of all of that is the author of that world. Similarly, we can ask a question like, it's a great bridge, why are sunsets red? Well, because blue light scatters more strongly off the atmosphere than red light. Okay? So that's why the sky is blue, but in the late afternoon, when the sky has to go through a lot more atmosphere, the sunset looks red. Same question, why are sunsets red? Because God wanted to make his universe that way. Now, because God is rational, that fact, sunsets are red, will fit in with a whole heap of other facts in a coherent scheme, just as all the events in a book fit together in a plot. But over the top of the whole thing is, of course, the creator of the whole order, who for this slide will be played by J.K. Rowling. Given what I'm trying to say here, it would be a bit counterproductive to put a just bearded dude in the sky, right? That's exactly what I'm trying not to say. Once we see this, we see actually that science can only get you so far. There are fundamental, deeper questions. So I like this quote from a philosopher of science who is an atheist. His name is David Albert. But he said the following. Okay? The fundamental laws of nature generally take the form of, right, the ultimate laws of, whenever we found a fundamental law, they take the following form. They are rules concerning which arrangements of elementary stuff are possible and which aren't, or rules concerning arrangements of that elementary stuff at later times in terms of arrangement at earlier times, or something like that. The laws have no bearing whatsoever on questions of where the elementary stuff came from, why the world should have consisted of the particular elementary stuff that it does, as opposed to something else, or why there should have been a world in the first place. So something you never get out of science. And so if you have these deeper questions like, why does the universe exist at all? Okay? There's nothing we find in physics that's ever going to answer that. Why do we have a rational universe? Why is it the kind of place where when we reach out with rational questions, the universe hands us back rational answers? That is a precondition of science in the first place, so it's not the sort of thing you can get a scientific answer to. Finally, why a universe that supports life? I talked about that last year, right? If you change the fundamental laws in a very small way, we find out that actually our universe's ability to make complex things like life forms is extraordinarily rare. We saw an example of that at the beginning. There is order at the start of our universe, loads of it. If you want a universe that does anything interesting like making people, then you need to put that order in at the beginning. Okay? If you would like me to go on about that for another 350 pages, then you'll enjoy the book. So here's my second to last slide. The choice is not between science and God. Okay? Science fits beautifully within a Christian worldview. When I do science, I'm reaching out with rational questions. The rational answers I get back are because there is a mind behind the universe. I am discovering God's order there. Okay? I can't just do it sitting in a chair. I have to actually go and look. The choice is really between God and something called naturalism. Naturalism is the idea that the natural world is all there is. That physical stuff is the only stuff. And what's really important is that naturalism is not a competing answer to these questions. Naturalism is the claim that these questions do not have answers at all. Naturalism is the claim that there are no true facts that answer these questions. The naturalist must not convince you that they have a better answer, but that you didn't really want an answer in the first place. That is the choice that is before you. It is not a choice between God and science. It's a question of whether the questions that are deeper than science have answers at all. And with that, I will plug the book. As of 3 days ago, it's available in Chinese. We just got an email saying, hey, we did it. Oh, wonderful. I don't know if that's useful for anyone, but that's a true fact. I'm the worst salesman you've ever seen. Let me just finish with that point there, though. But when I could write that book with my friend and colleague Geraint, because who's an atheist, we could write that and agree on so much of it because we are asking the same rational questions of the universe. Okay, we both do science, and we can write 7 chapters, 300 pages, of the science that we both do together. Okay, him an atheist, me a believer. But at the end of the day, the question is not what we do, is what we do with the science we've discovered. Right? These deeper questions, do they point to an answer, or is there ultimately no answer there at all? Thank you very much.
Let's kick it off, Trav. Question number 1. Can you please explain how evolution aligns with Christianity and the book of Genesis? How did dinosaurs fit into that story?
Well, let me just solve this problem once and for all. I made that joke here last year. Good. It's still good, yeah. I'll make it next year. There's obviously a range of views on this, okay? Famously, there's a range of views on this. There are the people who think that Genesis gives a historical account of the way of sort of the history of the universe, Genesis chapter 1 specifically, which constricts the age of the universe to somewhere between 6,000 and 10,000 years. Maybe you can add another 10,000 or something. But if that happened, then there's no time for evolution, so that whole theory doesn't work. And then in that case, dinosaurs are just part of the original creation, but then die out for the same reason that anything else dies out. Whatever reasons, the same reason we have extinctions today. That's one half of the story, so that's called the young Earth creationists. My view is not that one, although I was sort of brought up in that. My view would be that Genesis is fundamentally teaching us the sort of points I was making before about both who God is and what his creation is like, that it is rational and good and dependent on him. In that case, if there's no sort of time scale in Genesis, then the question of how the universe started off and what happened since the beginning is a question for science. You just get your telescope out, get your paleontologist, and you try and work out that. It's a question like, the Bible doesn't answer every scientific question we have, so there's a whole heap that go into you just have to go and look. Genesis, the Bible won't tell you how many rings Saturn has, so you have to go and get that telescope. So in that case, dinosaurs are just a thing that happened in the past. The point I want to make is it's often claimed by atheists especially that if evolution happened, then that proves that life can just happen without any input, without anything special at the beginning. Right? The reason one of the applications of the first half of my talk is anything only ever happens in the universe because it had an orderly, special beginning, including evolution. If evolution happened, it is not order coming from disorder, because that breaks the second law. Right? You have to start with a universe with a whole lot of useful energy in it. You have to find a way to harness that energy to make life, and none of that comes for free. So those are the two views.
All right, next question. If God fits well within a Christian worldview, how can science explain creationism and the many different interpretations of Genesis in the Old Testament?
The fact that there are many different interpretations of a very old book is hardly surprising. It was written so there's a saying about the Bible that I find very useful. The Bible was written for you, but it was not written to you. It was written for an ancient, it was written to that ancient audience, and we have to try very hard to get back into the listener's shoes to try and hear what it's saying in that context. And obviously, when you do that, some people come up with different interpretations of the way the Bible works. Now, so that's hardly surprising. With any book, you do the best to interpret it the best that you can. So yeah, there's half of this, as I said, there's the people who think that Genesis gives an account of the way the universe actually started, and then you've got a whole lot of explaining to do about why the universe looks the way it does, or you think it doesn't, and then that is a question which is just handed to science, like a whole heap of other questions we have about the universe. The point I've made about science fitting within a Christian worldview is really why you would do science in the first place, because you expect there to be rational rules out there waiting for you to discover.
Okay, next question. Roughly what proportion of today's hardcore scientists are Christians? Is there a difference between now and the 1500 to 1700 era? If so, why do you think that is?
Yeah, I think there is. Although it hasn't changed. So when surveys were done about 100 years ago, the fraction of scientists who believed in a personal God, not just some form of God, but a God who would answer prayer, I think is the specific thing, was about 40%. And today, it's still roughly there, the last thing I saw. But that is lower than the population as a whole. I think it's certainly lower than it was in 1500 to 1700. I think there's a couple of reasons. I think there certainly is a rise of atheism, especially, as I said, French Revolution, all that sort of stuff. I think that comes primarily out of philosophy rather than out of science. It then sort of infects science from philosophy. That's one reason. I think today a major part of the reason why there are more atheists in science than in the population at large is, well, think about it if you're an atheist and you're trying to think what career you want to do. If you're a naturalist and you think that science is basically the only valid form of knowledge that we have, then there's something quite enticing about that as a worldview. Science is held up in very high esteem by naturalists for obvious reasons. The natural world is all there is, and all this other stuff is just, secondary and garbage. So there's a sociologist called Elaine Eklund from Rice University who's interviewed a large number of scientists about this, and it seems to be the case that it's not that a random sample of the population goes into science and then turn out atheists at the other end. More atheists come in the front door, right? They're just drawn into that particular field. So it would be nice if Christians started turning that balance around. There's a lot of things you could do with your life, but being a scientist, I think, is a good one.
Okay. Why does your mate who wrote the book with you not believe in God?
Well, I'm still working on it. No. One of the great things was there's a skeptical podcast. I forget what it's called. Anyway, Geraint was on that, and there was two atheists and then Geraint, so the three of them were talking around it, and they spent half their time talking about God because that was what was in the last half of the book. That entertained me no end. Geraint had an awful lot of, I don't want to speak for Luke, but, so let me start with, I don't want to speak for Geraint, but in the book, the problems he raises are really what God are you talking about is one of them. We've had all these ideas of gods throughout history. Why pick that particular one? Why pick the Christian one? I hope tonight I've given some of the case why that's one that sticks its head above the crowd as being credible. I think another thing is God, if you're in a scientific frame of trying to explain things, God seems like a bit of a non-explanation. You want to explain complex things in terms of simple things. And if you're thinking of God as a big beardy guy in the clouds, that seems like a more complex thing. You're just appealing to something that you're trying to explain things we know about, like the universe, in terms of something that's completely foreign and different and unusual and weird and, a necessary mind that has a spirit and all that sort of thing. So I think that's probably the reason there, although, as I said, I don't want to speak for him. I think the difference we have is is not really that, like, if you have the sort of wrong picture of God as beardy guy in the clouds, then the scientific evidence of fine-tuning sends you kind of in the wrong direction. Whereas for me, I think it fits nicely within my worldview, within the Christian worldview.
All right. Does the Bible help us understand science, or does science help us understand the Bible? Is it helpful to make scientific conclusions from what we read in the Bible? How scientific is the Word of God?
So I'm going to come back to that slogan again. The Bible is written for you, but not to you. So there's a passage in Ecclesiastes where the author says, all the rivers run to the sea, and yet the sea is not full. To the place where the rivers start, there the water returns. That's the water cycle. Now, I've seen Christians try to argue that that is something that God put in there as sort of miraculous scientific knowledge for us to know that it's written by God. The point that the author is making is that a lot of things in nature seem to just go round in circles, because he's going to say that human life just seems to go round in circles because it all seems pointless. It's a famously depressing book, Ecclesiastes. Okay? If his audience didn't know on some level about the water cycle, it would be pointless to use that as an illustration of the big point that he's making. It would be like him saying everything goes around in circle, like electrons around a nucleus. That would be a really stupid thing for him to say, because no one would understand the book of Ecclesiastes until about the year 1910, say. So I think, given that it's not written to us, we wouldn't expect to find scientific breakthroughs in the Bible, because then it would be meaningless to the people it was actually written to. I don't think we would expect to find scientific errors. We wouldn't expect that, of course. But the language for most of it is so poetic that again, it's describing the way that the universe appears to the people that were, the people it was written to at the time. So I wouldn't want to, in that sort of blunt way, go searching through the Bible for scientific information. It's more at this deeper level that if you take the view, especially of Genesis 1 on board, and there's other bits of the Bible too. Proverbs chapter 8 is this wonderful passage talking about wisdom. Get wisdom. And wisdom saying, I was there in the beginning with God. Wisdom is sort of personified as a woman who has, wisdom. I was there at the beginning when God laid the foundation. Just saying that the world is rational because it has a rational, wise God behind it. I think, given that that's the case, the goal of discovering about the world is something that God has left up to us. And so I wouldn't expect there to be sort of blatant scientific errors in the Bible. I don't think there are. But again, on the other side, I wouldn't expect there to be, if we just turn this way and read every second word, we'll get quantum mechanics out of the Bible. I don't expect that to happen either. I wish that was a hypothetical example.
I'm going to go home tonight. Can you tell us about dark matter?
Oh, yeah.
Is that actually a thing or a new name for nothing?
Okay. Whenever you see anything, you see the wall over there, what you're really seeing is light bouncing off the wall. The reason why light starts over there, heads over there, the reason it bounces when it goes over there is because in the atoms in the wall have charged parts of them, electrons and protons, right? Charged particles, light is an electromagnetic wave, those interact, and so the light takes a right angle, a turn off the wall and heads towards your eye, and you can see the wall. If light didn't interact with the wall, right, as it's not doing with the window very strongly, it would just go through. If there was a form of matter which didn't interact via that particular force, electromagnetism, we wouldn't see it because light wouldn't bounce off it, and it might not interact very strongly with itself, so it might not generate light in and of itself, and so it would be dark. But it would have gravity, because it's still there, it's still got mass. When we look at our galaxy, there should be a relationship between how much stuff there is, how much matter, which is holding things together with gravity, and how fast the whole thing is rotating. Okay? With this amount of stuff, how fast can I keep things in orbit? And there's a mismatch. There's only about 10% of the stuff we need to hold the galaxy together. Hence, we think there is something called dark matter. And there's a couple of other lines of evidence that seem to point the same way. So that is dark matter. Obviously, if we knew what it was, we wouldn't call it dark matter. You only tell something that if you don't know what it is. But the evidence is only via its gravitational effect, not via the way you see the world, which is via electromagnetism. And so there's less evidence for it than all the other forms of matter, but there's several lines of evidence which seem to be pointing in the same direction.
How does the idea of original sin fit into the story of the universe?
Right. The other thing about creation is, of course, that it's fallen, according to the Bible. When I last gave this talk, I just said creation is fallen. That's a topic for another time when I'm not here. Just hand that over. So all I want to say about it is, there's a famous psalm about creation, Psalm 19, which says, "The heavens declare the glory of God." It doesn't say, the heavens used to declare the glory of God and then you guys ruined it. Okay? They still do. So that picture I've sort of painted of a beautiful universe is still there, even though it's tainted. So there is sort of, I think Pascal says something like this, we have the feeling of the universe around us that it's a great thing gone wrong. Particularly people, when someone lets you down, you have the feeling of something with incredible potential to do something amazing, and they've sort of done something awful with them. So we have that feeling about the universe as well. There's in Romans 8, Paul talks about creation being sort of subject to decay. That the universe is a good and great and wonderful thing, but it's dependent and it's not ultimate. Right? It's not the sort of the end of the story. We don't feel at home here because it's not our home in its current state.
How old is the Earth? Does make the Bible more or less relevant and or scientific?
So, again, it depends how you interpret Genesis, the first couple of chapters of Genesis. From my interpretation, given that it's not trying to be a straightforward historical account of what happened, it's more about the relationship between creation and creator. The age of the Earth is not then a question that gets answered by the Bible. It's like the number of rings of Saturn. We just have to work it out some other way. Okay? Now, there's the other side of the story who say it does, and then they've got a lot of explaining to do about radio isotope dating and all of that sort of stuff. I don't have to worry about that. But so if the problem is simply handed over to science, the answer comes back at about 4.5 billion years old. We know that from the way that radioactive atoms decay inside of rocks, tells you when that atom was trapped inside that rock. It's an approximate method, but a number of different methods sort of arrive back at that rough answer. So again, if the problem is just purely one of science, as I think it is, that's the answer science gives us.
Okay. I can get on board with there being an intelligent designer, but why does it have to be the Christian God?
Good. So a Muslim could almost have given the talk I gave tonight. Almost. They have a similar picture of God. We stress a few things more than they do, but roughly that's the way it is. All that's telling you is if you want to decide between the different conceptions of God that fit that list that I gave. So for a Muslim, there would be ultimate and free and all of those things. That would be all the same. If you want to then decide between those options, you just have to have different evidence. So let me just keep using this example. Did Jesus of Nazareth die on a cross? If you answer that historically, you look at the historical evidence, that will rule out one or the other of those two, because Muslims believe that he didn't. It's in the Quran. All that's telling you is you don't ask a physicist. Just you have to ask history. You have to look at sort of other criterion to try and decide between the different ideas of God that are out there. I think there's a whole swathe of ideas of God that go by the wayside. So Zeus is not the sort of God that would underpin the kind of things I've been talking to tonight about a rational universe, right? The sort of guy who gets drunk and does things that are completely X-rated, right? That guy's gone, thank goodness. But within the sort of great monotheisms, within Judaism, Christianity, and Islam, and there's a few others around, you're just going to have to decide on different criteria. You're going to have to go and read the New Testament and the Old Testament.
All right, well, given time... Sorry, one last question, and then we'll wrap it up there. So what's your biggest, oh wow, moment in science that supports your appreciation for the rare order of the universe?
What's your biggest, oh wow, moment in science that supports your appreciation for the rare order in the universe? Good question. There's something that really impresses cosmologists. So when we talk about the Big Bang Theory, we're not really talking about the beginning point where you're told everything was at a point and it's infinite density and all that. All we really mean is, as a physical theory, that in the past the universe was denser and hotter. And that's it. That's the whole thing. And it was very smooth at the beginning. And sometimes in physics you make a sort of simplifying assumption just to sort of get on with it. And then you keep your eye out for where that assumption might fall apart and you need to do something more complicated. So that's a very simple, let's just assume the Big Bang model is very simple. Let's assume the universe is the same everywhere, roughly on average, and in the past it was hotter and denser. How far can we push that back? Well, it would seem ludicrous to push it back to 1 second after the beginning of the universe. But that's when the universe is hot enough to ignite, to allow, actually cool enough if you run it the other way, never mind, to allow nuclear reactions to happen. Now, we understand how nuclear reactions work, and so we can ask the question, if that happened, how much of the heavier elements, heavier than just single protons and neutrons, would we expect there to be in the universe? And the remarkable thing is we get a lot of those numbers very close to right. We predict the amount of helium-4 in the universe, the amount of helium-3, the amount of deuterium, which is a proton and a neutron. Actually, we get lithium-7 slightly wrong, which is interesting. But the fact that we can, that's an oh wow thing, right? There's a very good science writer called Paul Davis who heard in a lecture in the late 1960s, when he was around, starting in science, that they were going to use the Big Bang model to predict what happened 1 second after the Big Bang. And the entire class erupted into laughter, right? That's a ludicrous idea. And yet, when these calculations were done, and the great thing is they were done by a student of one of the critics of the Big Bang, known as Fred Hoyle. He got his student to do it, hoping it would disprove the Big Bang. They all sort of lined up right. So this is called Big Bang nucleosynthesis. And that's kind of amazing that we can push the idea back that far and still make predictions about the universe.
Good place to end it. Could you please thank Dr. Luke Barnes?
Thank you very much. Thanks for coming out.
I had a couple of people ask me best way to access your book. I presume Amazon, or is there another way?
Yeah, it's available on ebook, so Amazon, Kindle. There's an audiobook version on iTunes and Audible and Amazon. That took us ages to do. Please buy that. There's a hardback book. Probably Book Depository is the best for that. When we want to order them to then sell them on, we buy them from Book Depository and not from our own publisher because they're cheaper on Book Depository. Anyway, and if you want to learn some Chinese and have some practice, then there's a Chinese section.
Thanks so much for coming tonight, guys. Yeah, good night.
Thank you.